Velocity is one of the most important concepts in physics. It describes how fast an object moves and tells us about both speed and direction. Velocity is defined as the rate at which an object changes its position. This means velocity tells us how quickly something moves from one place to another. Let's use a simple example to understand velocity. Imagine a car traveling down a straight road. To calculate velocity, we need two key pieces of information. First, we need to know the distance the car travels. Second, we need to know how much time it takes for the car to travel that distance. Watch as our car moves from the starting point to the ending point. As it moves, we can measure both the distance it covers and the time it takes. Velocity is more than just speed. It combines three important elements: the distance an object travels, the time it takes to travel that distance, and the direction of motion. Understanding this relationship between distance, time, and direction is the foundation for calculating velocity. In the next section, we'll explore the mathematical formula that connects these concepts. The velocity formula is one of the most fundamental equations in physics. Here it is in its mathematical form: v equals d divided by t. We can also write this in words: velocity equals distance divided by time. This simple relationship connects three important physical quantities. Let's break down each variable. The letter v represents velocity. This tells us how fast something is moving. The letter d represents distance. This is how far something travels from one point to another. The letter t represents time. This is how long it takes for the journey to happen. Here's something crucial to remember. Your units must be consistent. When measuring distance, you can use meters, kilometers, or miles. For time, you can use seconds, hours, or minutes. The key is that both distance and time must use the same system of units. So remember, velocity equals distance divided by time. This fundamental formula connects how fast something moves with how far it goes and how long it takes. Velocity has specific units that come from combining distance and time measurements. Understanding these units is crucial for solving physics problems correctly. The two most common units for velocity are meters per second, abbreviated as msecs, and kilometers per hour, abbreviated as kilometers per hour. Meters per second is often used for walking or running speeds, while kilometers per hour is common for vehicle speeds. Velocity units are formed by dividing distance units by time units. When we measure distance in meters and time in seconds, we get meters per second. When we measure distance in kilometers and time in hours, we get kilometers per hour. To convert between these units, we use conversion factors. To convert from meters per second to kilometers per hour, multiply by 3.6. To convert from kilometers per hour to meters per second, divide by 3.6. The factor 3.6 comes from the relationship between the units. 1 kilometer equals 1,000 meters, and 1 hour equals 3,600 seconds. When we divide 3,600 by 1,000, we get 3.6. Here's a quick example. Let's convert 15 meters per second to kilometers per hour. We multiply 15 by our conversion factor of 3.6. 15 times 3.6 equals 54. Therefore, 15 meters per second equals 54 kilometers per hour. Understanding velocity units and how to convert between them is essential for solving physics problems. Remember that the units come from dividing distance units by time units, and use 3.6 as your conversion factor between msecs and kilometers per hour. Let's solve our first velocity problem step by step. A cyclist travels 100 meters in 10 seconds. What is their velocity? First, let's identify what information we have been given in the problem. Step 1. We identify the given values. The distance is 100 meters, and the time is 10 seconds. Step 2. We recall the velocity formula. Velocity equals distance divided by time. Step 3. Now we substitute our known values into the formula. We replace d with 100 meters and t with 10 seconds. Step 4. We perform the division. 100 divided by 10 equals 10. So the velocity is 10 meters per second. Therefore, the cyclist's velocity is 10 meters per second. This means the cyclist travels 10 meters every second. Here's our second example problem involving different units. A car travels 120 kilometers in 2 hours. We need to find its velocity. Step 1. Let's identify the given values from the problem. The distance is 120 kilometers and the time is 2 hours. Step 2, we apply the velocity formula. Velocity equals distance divided by time. Step 3, now we substitute our values into the formula. Velocity equals 120 kilometers divided by 2 hours. Step 4, we perform the calculation. 120 divided by 2 equals 60 kilometers per hour. The car's velocity is 60 kilometers per hour. Notice that our answer includes the proper units, kilometers per hour, which tells us both the magnitude and direction of the measurement. Now that we understand the basic velocity formula, we can rearrange it to solve for different variables. This is a powerful algebraic technique that allows us to find distance or time when we know the other two values. To solve for distance, we need to isolate d on one side of the equation. We can do this by multiplying both sides by t. Now let's rearrange the original formula to solve for time. We need to isolate t by multiplying both sides by t, then dividing both sides by v. Now we have 3 versions of the same formula. Each one allows us to solve for a different variable when we know the other two. Let's see these formulas in action with quick examples. First, finding distance. If a car travels at 60 kilometers per hour for 2 hours, the distance is 60 times 2, which equals 120 kilometers. Now for finding time. If we need to travel 150 kilometers at a speed of 50 kilometers per hour, the time needed is 150 divided by 50, which equals 3 hours. By rearranging the velocity formula, we can solve for any variable as long as we know the other two. This makes the velocity formula incredibly versatile for solving real-world problems. Velocity calculations aren't just academic exercises. They're essential tools used in countless real-world situations every single day. In transportation, velocity calculations are everywhere. When you're driving a car, your speedometer constantly calculates and displays your velocity by measuring how much distance you cover over time. Airlines use velocity calculations to determine flight times, fuel consumption, and arrival schedules. Air traffic controllers rely on these calculations to safely manage aircraft spacing and landing sequences. In sports, velocity calculations help athletes and coaches analyze performance. Track and field coaches time runners to calculate their average velocity over different distances. Swimming coaches use velocity calculations to track improvement in lap times. Cyclists monitor their velocity to optimize training and race strategies. One of the most practical applications is trip planning. Let's say you're planning a road trip from your city to a destination 240 kilometers away, and you want to arrive in exactly 3 hours. Using the velocity formula, we can calculate the required average speed. We need to travel 240 kilometers in 3 hours, so our required velocity is 240 divided by 3, which equals 80 kilometers per hour. Velocity calculations are also crucial in many other fields. Engineers use them to design safer vehicles and structures. Scientists apply them in physics research, weather forecasting, and space exploration. From planning your daily commute to launching rockets into space, velocity calculations help us understand and predict motion in our world. These mathematical tools turn abstract concepts into practical solutions for real problems. Now it's time to test your understanding with some practice problems and review the key concepts we've learned about velocity. Here are 3 practice problems for you to solve. Try to work through each one before I show you the solution. Problem 1. A car travels 150 meters in 10 seconds. What is its velocity? Take a moment to calculate this yourself. The solution is velocity equals distance divided by time. So 150 meters divided by 10 seconds equals 15 meters per second. Now let's try problem 2. Problem 2. A cyclist travels at 8 meters per second for 25 seconds. How far does the cyclist travel? Remember, you'll need to rearrange the velocity formula. The solution is distance equals velocity times time. So 8 meters per second times 25 seconds equals 200 meters. Here's our final practice problem. Problem 3. A train travels 540 kilometers at 90 kilometers per hour. How long does the journey take? This time, you need to find time. The solution is time equals distance divided by velocity. So 540 kilometers divided by 90 kilometers per hour equals 6 hours. Now let's review the key concepts we've learned about velocity. Here are the key concepts. First, the velocity formula. velocity equals distance divided by time. Second, remember the common units, meters per second and kilometers per hour. Third, the rearranged formulas, distance equals velocity times time, and time equals distance divided by velocity. Remember, practice makes perfect. Keep working through velocity problems to master these concepts. The more you practice, the more confident you'll become with velocity calculations.